Hey everybody, so today we're going to be talking about zeros of quadratic functions. Now what are zeros? Zeros, which are sometimes called roots of a quadratic function, f of x, these are just the values of x for which f of x is equal to 0. In other words, they're the x values that if we plug it into the function, we're getting 0 out, which is why we call them zeros. Now, how do you find zeros of a quadratic function? Well, it really depends on what form your quadratic function is in. So remember from the reading and from class, there's 3 forms of a quadratic function. You have standard form, f of x equals ax squared plus bx plus c, factored form, a times x minus r times x minus x, and vertex form, f of x equals a times x minus h squared plus k. So depending on the form your quadratic function is in, I'll recommend a different type of process for actually finding zeros. Okay, so let's look at some examples. All right, so f of x equals x squared plus 5x plus 6. Now there's 2 ways I'm going to show you to solve this. The first way is factoring. And you're going to notice both ways do start off the same way. So if you're ever finding the zeros of a function, you always start by, well, setting the function equal to 0. Okay. Now the way we're going to solve this first is we're going to factor it. If you can factor your quadratic equation, you're really in a good spot, and it's really the most efficient and fast way of finding the zeros. Now notice this quadratic function here does factors really nicely into x plus 3 times x plus 2. Okay. And now that we have it factored, we can use the zero product property. Remember, if 2 numbers multiply to 0, then that means that one of them has to be 0. Okay, so what this means for us is this means that either x plus 3, our first number here, equals 0, or our second number, x plus 2, equals 0. Okay, and once we have this, we just solve for x and we call it a day. So our first line here, we're going to get x is equal to minus 3. In our second line here, x is equal to minus 2. Okay, so this is what I would call the factoring way. And again, if you can factor, you are in good shape. It's going to be very, very nice to find your zeros. Now, the second way, and this takes a little bit more time, but it is always a good way if you have the right form, is the quadratic formula. Okay. So if we have x squared plus 5x plus 6 is equal to 0, remember the quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So again, this using the quadratic formula, as long as you can identify your a, b, and c, it will work. But notice here, it's not the nicest looking formula, so sometimes it can take a lot of time. But in any case, let's go ahead and solve it and make sure that we get the right answers. Actually, I forgot to box my answers up there. All right, so b is 5, so we have negative 5 plus or minus the square root of 5 squared, so 25 minus 4 times a times c. And actually here, let me go ahead and write while we're at it, b, c, and then a here is secretly 1. So 4ac is going to be 4 times 1 times 6, which is 24, all over 2 times a, 2 times 1. And simplifying, this is negative 5 plus or minus the square root of 1 over 2, which if we simplify this, this is negative 5 plus 1 over 2, or negative 5 minus 1 over 2. Okay, so negative 5 plus 1 over 2, that's going to be negative 2. And then negative 5 minus 1 over 2, that's negative 3. Okay, and so notice we do get the same answers as we did above here, but it took a little bit more work though. Okay, so again, what I recommend, if you have a quadratic equation in standard form, try to factor, because that will give you your answers a lot faster. But if you can't factor it, quadratic formula is always a good alternative, but again, it does require a bunch of arithmetic. Okay, so it's a balancing game. All right. Now, if your quadratic equation is in in factored form, like we have in number 2 here, then pretty much all the work has been done for you. We use the zero product property again, we're pretty much good. So we start by, again, setting our function equal to 0. Okay, and now we set each piece equal to 0 and call it a day. And notice here, I don't have to worry about the 4 because is 4 equal to 0? Absolutely not. So we don't have to worry about that. But x plus 5 could be 0, and x minus 6 could be 0. So solving for x, we get x is equal to, from this equation, minus 5, and we get x is equal to 6 from this equation. So our zeros would be minus 5 and 6 in this case. Lastly, what if your equation is in vertex form? Okay. So we start by, again, setting our equation equal to 0 if we're trying to find the zeros. And the way we solve for the zeros in this case is we're going to use something called the root method or the square root method. Okay, so what we're going to do is we're going to isolate the x plus 5 squared here. So I'm going to add 6 to both sides. Okay, so we get 6 is equal to 2 times x plus 5 squared. Divide both sides by 2. So we get 3 is equal to x plus 5 squared. So now that we've isolated the squared bit of our function, we just take the square root of both sides to get rid of the square. Now be careful, when you take the square root of both sides, what do you have to do? You have to add a plus or minus here. All right. So we get, in this case, plus or minus the square root of 3 is equal to x plus 5. And now notice we don't have the squared there anymore, so we can solve for x really, really nicely. Let's move the 5 over to the left. And so we get negative 5 plus or minus the square root of 3 is equal to x. So notice we have two zeros here. We have negative 5 plus the square root of 3 and negative 5 minus the square root of 3. It's kind of hidden in that plus or minus. But in any case, this is what you do. If you have a quadratic function in vertex form, you use what's called the square root method or the root method. And the reason why we call it that is because, well, we used a square root here at some point. In any case, this is how you find zeros of your quadratic function.